So let's talk about one of the biggest challenges in AI right now. How do we build coding agents that are more than just, clever toys? We're talking about real professional grade tools that are built with actual engineering discipline. And we're about to dive into a blueprint for how to get that right. It really all comes down to this question. I mean, any chatbot can spit out a code snippet if you ask it to, but can it safely and reliably maintain an entire code base? That's the real challenge, right? And it's an order of magnitude harder to pull off. And this is where VT Code comes into the picture. It's an open source project, but it feels less like an experiment and more like a really thoughtful plan for building these agents the right way. It's got this deep focus on being modular, secure, and actually understanding code right from the very beginning. Okay, let's start with the foundation. When you're building software, architecture isn't just some boring implementation detail. It's what decides if a project can actually grow and adapt, or if it's just going to collapse under its own weight down the line. And this is where VT Code's first big idea really shines. This slide really says it all. Instead of building one giant monolithic application where everything is tangled together, VT Code smartly separates its core logic, that's the VT Code core library, from the command line tool you actually interact with. And this is a total game changer, because it means other developers can just grab that core library and build their own custom tools on top of it. And that same idea of flexibility extends to how VS Code talks with your editor, all thanks to something called the Agent Client Protocol, or ACP. Now, if you've ever used the Language Server Protocol, LSP, you'll get this immediately. LSP lets any editor support any programming language. Well, ACP does the same thing, but for AI agents. It lets VS Code plug into editors like Zed without being trapped in just one ecosystem. And get this, the flexibility even extends to the AI models themselves. VT Code isn't hardwired to OpenAI or Anthropic or Gemini. Nope, it has this abstraction layer that lets you plug in dozens of different models. You can even use local ones running on your own machine with Allama. This means no vendor lock-in. You have total freedom to pick the best, or the fastest, or the most private model for whatever you're working on. Okay, so the foundation is solid. But what about the brains of the operation? This is where we see that massive leap from a simple text-generating chatbot to a true coding assistant that actually understands the craft of programming. All right, look at this. On the left, you've got the old way, trying to mess with code using these clunky, fragile text patterns called regular expressions. It's like trying to edit a book by only looking at the individual letters, not the words or sentences. But on the right, that's the VT Code approach. It uses tools like treesitter and ast-grep to understand the code's actual structure, its grammar. This lets it use these clean, semantic patterns that are just way more powerful and reliable. Let's see this in action. Make it real. Here's a pretty standard synchronous function in Rust. A super common task for any developer is to switch this over to be asynchronous so it doesn't block everything else from running. And boom, here's the result. Now notice it didn't just slap the async keyword on the front. It understood the function's signature, it updated the return type, and it knew to add that critical .await call inside. That is a true structural refactoring. A simple text-based find and replace tool? No way, it would completely fail at this. And this really gets to the heart of the philosophy behind the project, with this quote from the developer. String manipulation produces chatbots that generate code. Structural comprehension produces refactoring tools. I mean, that's not just a clever line, it's the whole idea driving this thing. Now let's talk about another huge challenge for any serious AI agent, the limited memory or context window of these large language models. If an agent can't remember what you talked about at the beginning of a long session, it's just never going to be able to handle complex, multi-step tasks. So how does VT Code solve this? Well, its context engineering system is so good that it can handle interactive coding sessions that go on for more than 100 turns. And it does all of that without a human having to jump in and remind it what's going on. And here's the breakdown of how it works. It's not magic, it's just really smart engineering. When the conversation gets too long or starts hitting its token limit, the agent automatically uses an LLM to summarize its own history. This keeps all the critical info, the why behind its actions, and it frees up thousands of tokens so it can keep working without losing its train of thought. Now, the secret sauce that makes that intelligent summary possible is this concept called the decision ledger. The best way to think about it is like the agent's own professional work journal. It's a structured record of every choice it made, every action it took, and what happened as a result. This lets it look back, stay on track, and pull off really long and complex programming jobs. All right, next up is a topic that is absolutely non-negotiably critical for any AI agent: security. I mean, think about it. Giving an AI access to your terminal and all your local files, that's inherently risky. You have to build trust right into the architecture from day one. Yeah, a command like this is the kind of thing that gives developers cold sweats. If an AI agent could be tricked into running something this destructive, the whole idea is dead on arrival. This is exactly why you can't just bolt security on as an afterthought. It has to be baked in from the very start. So VT Code's solution is what's called a defense-in-depth strategy. It's not just one lock on the door, it's multiple layers of protection. First, it uses sandbox execution, leveraging technology from Anthropic to keep processes isolated. Then, it adds strict path validation, which stops the agent from snooping around your file system. And finally, for anything that could be risky, it puts a human in the loop. It has to ask you for permission. And this, right here, is where the trust is really earned. You, the developer, get granular control. In this simple configuration file, you can set specific policies for each project. For example, you could say, sure, the agent can read files whenever it wants, but it has to ask me for permission every single time it tries to write a file or run a command. You're the boss. Okay, so we've looked at modularity, intelligence, memory, and security. What does all of this tell us about where AI developer tools are heading? Let's bring it all together. So we've seen 5 core principles from the way VT Code was engineered: a modular architecture, which is built to last; provider abstraction for total flexibility; structural intelligence, so it's more than just a chatbot; automated context management to handle real-world complex tasks; and security by design to actually earn our trust. This final quote just captures the entire philosophy perfectly. Sustainable agents are infrastructure, not experiments. The point isn't to build some flashy feature that's going to be obsolete in 6 months. The goal is to build reliable, secure, and extensible infrastructure that the whole developer community can build on top of for years to come. You know, these kinds of tools aren't science fiction anymore. Production-grade agents, built on solid engineering principles, just like these, are actually here. And that leaves us with one pretty provocative question to think about. Is your codebase ready for an AI maintainer?